Everyone, today I'll be doing my presentation on the microbit and how it uses the accelerometer readings to give a step count in a specific time interval. The mathematical concepts I'll be using is basically x, y, and z are the three axes. They are merged, and this equation helps to give me one magnitude value. As you can see, it has printed welcome to step counter. Your 5 minute interval has started. And here, if you can see, 10 seconds of has byte as 450. If we try to count the steps, it works perfectly. And the time is going on 440, and it will by 430. Just make sure time is working, and so does the step count. I will fast forward this video until the 5 minutes are over. About 9 seconds left. I know I should have printed 10 seconds. The reason is because I've put a delay, so there's no fast movements. So time's up. And if you go here, your step count in the 5 minute interval is 16. So if I try to move, it doesn't cause any movement or any step count. The reason is because I've stopped the step count once the 5 minute interval is over. But if I were to press A, it will start the count. And if you see, it will start the timer for. My code goes through three basic mechanisms. Firstly, it's the movement of the microbit, which senses the accelerometer reading and gives the step count output. Secondly, it's the microbit grid, which displays the time after every passing 10 seconds. And thirdly, I'm using one button, which is button A, which resets the time once the time interval has ended. So these are the libraries I have used for this code. I have set the threshold to be 2500. Although the peak of the accesses were 2000, I increased by 500 because it gave me a better efficiency in counting. And these are basically the variables to count down time. Total time is 5 minutes. I've changed it into milliseconds because I'm using millis function, which counts in milliseconds. And these are the bool statements: times up, step count, and reset, which helped me get the reset valuation. So in the void loop, um, the the mathematical concept which I mentioned is right here. This helps me get the magnitude of the three axes. And once I do the movement, if that magnitude is greater than 2500 and the bool value is true, which gets true here, it will increment the step count. And this is just a bool statement. I will explain what happens to it later on. Else, if the magnitude is less than threshold, it stays false. So this part of the code calculates the time. So basically, what happens is this part of the code calculates the 10 seconds each time, and once that happens, it goes to the next if condition. So in this condition, it subtracts the 10 seconds from the first 5 minutes, and the remaining time would be displayed on the microbit. So what I do is, so for 50 minutes would be converted into the basically the beginning. If you go, it's in milliseconds. So I have to convert it into minutes and seconds so I can display the time. So here I use this function to help me calculate the minutes. And then the remaining time would be converted into seconds. And I stored them in a time string. And I use this sort of format like a digital clock, which displays the minutes and seconds. And then I print it in the microbit. And once the remaining time is 0, this function would run, and the microbit would print times up, and this field print would print the last step count, and here the stop count is true. So here where I mentioned why I'm using this, this helps me get the last step count after it gets resetted. I mean after the count stops. And this is my button function. So if I press the button and it returns the step count, the threshold, last time, everything to its original position, which is false. And yeah, and that's how my code works. Okay, finally coming to the results of my project. The margin of error is plus minus 18%. I came up with this by counting 100 steps on BBC Microbit, and secondly counting 100 steps on my phone. And I saw when the phone reached 100 steps, at that time the Microbit had like 72, 71 counts. The challenges I faced: firstly, the time countdown made step count to not run when I first programmed. So I had to update my time count in order to print the step count. Future recommendation: I would probably choose to write my code on VS rather than Arduino. Arduino is quite outdated and it doesn't have the new features which VS has. Secondly, I'll try to have a better efficiency in the step counter when there's a time interval. And that's it. Thanks for watching.